I wanted to make a battery charger for my car because I have this car that I rarely use, and one day when I want to start it, the battery might be flat. Talking about the cheap side, the market has basically two types of models. One smart, switch mode power supply with a bit of electronics, and another dumb charger, just a transformer and a bridge rectifier. The smart charger is good and fairly underpowered. Sometimes it does too much analysis of the battery and refuses to charge it for reasons unknown to man, or sometimes it starts charging and stops abruptly. The dumb charger charges no matter what, but the cheap ones are so bad it's an insult to the consumer. They are so underpowered, so poorly made, if it wasn't so tragic it would be laughable. I wanted to put my charger to the battery and connect it to a programmable power socket to periodically come to life and charge my battery. The smart ones cannot do that because when they powered up, you always need to press some buttons. The basic simplest car battery charger schematic looks like that. Simple is reliable, but I also added some safety features. To make this project, I'm going to use this transformer, which is 14 volts, 7.1 amperes, a rectifying bridge as powerful as I could find in my bin. I guess it is about 10 amperes. A bunch of resistors, which I am going to explain their use later. It's 20 watts 1 ohm and I have 5 of them. A capacitor rated 15,000 microfarads at 50 volts, which is what I found in my bin, but it is more than enough for our project, and it isn't even necessary for charging a battery. I'm going to use it because I can power some other devices. What else do I have here? Automatic fuse, which I'm going to test later and see how it works. A cheap Chinese volt amp meter rated 10 amperes. I use it because I have it, but it is not mandatory. I have a relay, which I'm going to explain later what it is used for. A automotive 12 volts 30 amperes relay. Of course, a power button and some power leads. This is for the mains and for battery connection with crocodiles. The electric diagram is fairly simple with some personal touches. We have the mains coming in, a power switch and the transformer, 14 volts, 7 amperes in my case. Then we are going to rectify this, and after rectification I've added a capacitor. The capacitor is not mandatory if you only intend to use this device as a car battery charger, but if you want to use it as a power supply to power other experiments, then a capacitor is well suited, and its value I would recommend about 1000 microfarads at around 40 volts. A general rule is that the rated voltage of the capacitor should be double the voltage that it is subjected to. In parallel with the capacitor, I added a resistor of about 1 kilo ohm. It has the purpose of discharging this capacitor when the power is off. Then I've added a relay. The relay has a diode in parallel. It is called a flyback diode. Its purpose is to prevent the huge voltage spike which appears when the power is cut off and all the energy stored in the coil of the relay surges back into the circuit. The relay is a 12 volts 30 amperes automotive type, and I'm going to explain its purpose immediately. It activates a contact, normally open, on the plus rail. Then we have a automatic fuse, a thermal fuse. This is its symbol. Its purpose is to protect the circuit if something bad happens to the output, like a short circuit or a too high current sink. And then I've added a voltage drop resistor of 0.5 ohms at around 40 watts, a huge resistor, which consists basically of two parallel 1 ohm resistor. Here I extract the power for the voltmeter. Here we have a voltmeter, volt ampere meter, and we measure the voltage across it, and the ampere is a series circuit, of course. And now we have the binding posts, the output. The volt ampere meter is powered with a separate connection. And here we connect the battery. How this circuit works? Well, when we turn on the power, obviously we have rectified output, plus and minus. The output should go straight to charge the battery, but in my case I've inserted this relay which energizes, closes the circuit through this protection fuse, and through this drop resistor it charges the battery. Well, this relay, its purpose is for the entire circuit to be protected, to not be powered by the battery itself when we turn off the power and the battery remains connected. In that case, the battery itself powers back the entire circuit. So what does it do? Well, it powers the voltmeter, and it also has as a load the secondary coil of the transformer, which is not good. In time it might discharge the battery. If this relay deactivates when the power is off, then the battery no longer powers the rest of the circuit, not even the voltmeter, because the voltmeter is actually powered from the first side of the circuit. The purpose of this drop resistor is to limit the current which the battery might sink. If the battery is very discharged and draws a huge amount of current, then this drop resistor will cause a voltage drop, and consequently the voltage supplied to the battery will decrease. As the battery charges, the current drops and the voltage slightly increases up to the maximum voltage of 14 volts. First I'm going to test this transformer to see exactly how many voltage we have at the output. First let me check the voltage of the mains here. 216 volts, not very much here at the outskirts. $14.2. Good, that's good. Next I need to solder the secondary to the rectifying bridge. $420 because it's a lot of surface which dissipates the heat. So now let's check out the continuous current, DC. Perfect. Next step is to solder the capacitor, but I forgot the polarity. That's it. That's the plus. I put a diode in parallel with the relay. Just an ordinary diode, any old diode will do. There's nothing fancy about it. Okay, we have a diode. The relay itself is not polarized, it doesn't have a polarity, but once we add the diode it's counter-polarized. So the line goes to plus and the bottom of this triangle goes to minus. Now this voltmeter has a circuit of power and a circuit of measurement for measurement. Okay, so I'm now wiring the power circuit directly to the bridge rectifier. Plus and plus and plus and plus, all the pluses. This one is for the actual power, the rest is auxiliary circuit. All the pluses are going to plus here. Okay, so the capacitor, the relay, the measuring device and the actual output all go to plus. So this was the positive rail and the negative rail. I've made all the connections and now I'm heat shrinking. So far nothing exploded. Plus and minus. Almost 18 volts. Not bad. So now we have a measuring device which measures now 0 volts, but it is powered from our transformer. Great! I want to test one of those so-called automatic fuses. This one is rated 5 amperes at 250 volts AC. I don't know how it is functioning with DC current at low voltages at around 12 to 14 volts. So I'm hooking up a variable resistor, powerful resistor, and I'm going to increase the current. So right now I have 3 amperes, all right? Ramping up the voltage. 4 amperes. The resistor is heating up. 5 amperes. Not triggering yet. It's getting a bit warm. So it's rated 5 amperes, but it's not triggering yet. Let's wait a minute or two. My variable resistor is smoking, but not triggering. Wow. Let's increase. Yes, now it triggered at around 6 amperes and my resistor is smoking. If I'm trying to reset it, it doesn't reset. Now it's resetting. Alright, let's see if it triggers again. Yes, it triggered again, but not very fast. Okay, that's good. Look what the resistor did, and it's very hot. So 5 amperes at 15 volts, it's not a joke. It's capable of melting plastic and even burning. Alright, now everything is connected. Let me plug it in and see what happens. Great, so the output voltage today is 17.8 volts, but not to worry, because this capacitor increases a bit the voltage. It's an increased voltage, but as soon as we connect a load, you'll see that the voltage drops considerably and comes back to around 14 volts that the transformer outputs. If we follow the voltage, We have the mains here coming to the transformers, come out to this rectifying bridge, the capacitor, which I said is not mandatory, then the plus passes through this relay, comes out, passes through this drop resistor, through this automatic fuse, out here. This is the output. I've connected a load to the plus, but for the purpose of the demonstration I'll soon connect it to the minus, and we will see the minus coming out from the bridge rectifier. It goes one wire to the capacitor and one to this measuring device to measure the current out here, and this is the actual output. If I connect these three resistors in series, we'll have a load of 3 ohms, and 14 volts divided by 3 ohms, it's around 3 amperes load. Yeah, so you immediately see that the voltage dropped to 12 volts and the current is about 4 amperes on a 3 ohms load, which is absolutely normal. The voltage drop is a result of this drop resistor here. You see its purpose, it's coming to place to perform a voltage drop in case of high current synced by the load, in our case by the battery. So if the battery sinks a lot of current, the voltage is limited by this resistor, a very simple mean to limit the current. It's very slightly warm. The load, yeah, it's a bit warmer. Now I have to make it all fit inside this case. So for that I'm going to have to cover these holes here and modify the front. Okay, job done, all the holes covered. That's about it, folks. Next thing, banana posts. The second binding post is secured. The next step is easy, just drilling the holes for the power button and the fuse. There we go. This part is a bit trickier because I have to make a square hole to fit this into here. To make a square hole, I'm going to use this tool. All right. Let's see if it fits. That's about how it should look. Half assembled. Yeah. I'm only curious if it still works. Let's try it. Yes, it does. It works. I need to thread this cable through here and connect it to the power switch and back to the transformer. So I have to drill some holes. You got it. This is a cable strain relief. I'm adding this sleeve for extra protection. This is a leather collar for when my dog was a puppy. I'm going to make a handle for this thing. It's a total of 14 centimeters, but my hands are a little bit smaller side. Look at me. Who else has got a black car charger with a red strap? That's bad, man. That's badass. This is how it looks like, all jacked up and ready to charge some badass batteries. Yeah, perfectly balanced. Ah, pretty baby. The final touch, rubber fit. Okay, starting at about 2 amperes, 15 volts, 2.5 amperes, 14 volts, 3 amperes, 13.5, 4 amperes, 12.5. I'm going to pause a little bit. Let's proceed with 4 amperes, 12.5, 5 amperes, 11.5. And for an even higher current, I put, and it triggered the safety. Perfect. Excellent. Let's see how it behaves with a small battery, which is fairly charged. As you can see, the battery does not power back the charger. I think it handles this battery beautifully. The current is slowly dropping as the battery charges.